Space has always captured our imagination. It feels mysterious, endless, and full of secrets waiting to be discovered. But with every mission into space comes danger. The smallest mistake can mean the difference between success and disaster. NASA has sent rockets, probes, and astronauts farther than anyone else, but some missions have pushed the limits of safety. Among them is one mission so risky, so daring, that it has been called NASA's most dangerous mission yet. What makes it so dangerous? And why would NASA take on such a huge risk? That is the story we are about to explore. When we think about space missions, we often imagine rockets blasting off, astronauts floating in zero gravity, and incredible views of Earth from above. But behind those beautiful images lies a truth that is far more serious. Space is one of the most dangerous environments humans have ever stepped into. Unlike Earth, space has no air, no atmosphere, and no natural protection. Every breath an astronaut takes depends on life support systems working perfectly. If something goes wrong, there is no quick rescue. Help is not minutes away. It could be days, weeks, or sometimes impossible to reach them at all. The temperature in space can swing to extremes that are hard to imagine. In direct sunlight, it can rise above boiling heat, but in the shadow, it can drop to hundreds of degrees below freezing. Every spacecraft must be built to survive both conditions at once, and even the smallest failure in shielding could put the entire mission at risk. Then there is radiation. Here on Earth, our planet's magnetic field protects us from most of the sun's harmful rays. But in space, astronauts are directly exposed to radiation that can damage their bodies and even their DNA. Long missions increase this risk, and no shield is perfect. Even tiny pieces of space debris can be deadly. A small rock the size of a grain of sand, flying at thousands of kilometers per hour, can punch a hole in a spacecraft. With thousands of pieces of debris already orbiting Earth, avoiding them is another challenge NASA must solve. All of this means that in space, there is no room for error. Every detail must be planned. Every system must be tested. And even then, danger is always present. This is why NASA calls space exploration one of the greatest risks humanity has ever faced. NASA's history is filled with missions that have tested the limits of human courage and technology. Every great achievement has carried the shadow of danger. Take Apollo 11, for example, the first mission to land humans on the moon in 1969. Millions around the world watched in awe, but behind the excitement was a terrifying reality. No one had ever tried something like this before. The chances of failure were high, and President Nixon even had a speech prepared in case the astronauts never made it back. Then came Apollo 13, a mission that showed just how quickly things can go wrong in space. An oxygen tank exploded on the spacecraft, leaving 3 astronauts stranded almost 200,000 miles from Earth. For days, their lives hung by a thread as engineers on the ground worked around the clock to bring them home. It was a near disaster, and yet it also proved how determination and teamwork could overcome impossible odds. But not every mission had a safe ending. In 1986, the Challenger shuttle broke apart just 73 seconds after launch, killing all 7 crew members on board. 17 years later, tragedy struck again with the Columbia disaster, when damage to the shuttle's wing caused it to disintegrate on re-entry. These painful moments reminded the world that space exploration comes with a heavy price. Still, despite the risks and losses, NASA never stopped. Each failure led to stronger designs, better training, and more advanced technology. Every mission became a step forward, built on lessons of both success and tragedy. It is within this history, this long struggle between danger and discovery, that NASA's most dangerous mission yet was born. Among all of NASA's bold missions, one stands apart as the most dangerous of them all, the Parker Solar Probe. Launched in 2018, this spacecraft was designed to do something no other mission had ever dared, to fly directly into the outer atmosphere of the Sun, a place so extreme that no human-made object had ever survived there before. Why would NASA take such a risk? The answer lies in the mysteries of the Sun itself. The Sun gives life to Earth, but it is also capable of destruction. Solar storms can knock out satellites, damage power grids, and disrupt communication systems across the globe. By studying the Sun up close, NASA hopes to understand its violent behavior and protect our planet from its outbursts. But sending a spacecraft toward the Sun is like flying a paper plane into a fire. The Parker Solar Probe must face heat of over 1,300 degrees Celsius, hot enough to melt almost any material on Earth. To survive, it carries a special heat shield that keeps its instruments safe. But even with this protection, the spacecraft is flying closer to the Sun than Mercury, where conditions are beyond anything we can imagine. This mission is not only about technology. It is also about pushing the limits of human ambition. The Parker Solar Probe is flying through danger every moment, knowing that a single failure in its shield, its cooling system, or its navigation could mean the end. And yet, the knowledge it gathers could change how we understand the Sun and safeguard life on Earth. This is why the mission is seen as one of NASA's greatest risks and one of its greatest opportunities. The Parker Solar Probe faces challenges that no spacecraft has ever dealt with before. Every second of its journey is a battle for survival. The greatest danger, of course, is the Sun itself. The spacecraft must fly closer to the Sun than any mission in history, where the heat can rise to more than 1,000 degrees Celsius. Its heat shield, just a few inches thick, is the only barrier between survival and instant destruction. If even a small part of that shield fails, the probe will be gone in seconds. But heat is only one problem. The Sun also releases intense radiation and powerful streams of charged particles. These solar winds move faster than anything on Earth and can damage electronics, disrupt communications, or even destroy delicate instruments inside the probe. Engineers had to design systems that could keep working even while being blasted by this invisible storm. Then there are micrometeoroids, tiny pieces of rock and dust that race through space at incredible speeds. Even a grain of sand, hitting the spacecraft at those speeds, can cause serious damage. The Parker Solar Probe must survive countless impacts as it flies through regions filled with debris and particles thrown off by the Sun. On top of that, communication itself becomes a challenge. The closer the probe gets to the Sun, the harder it is to send signals back to Earth. The Sun's energy creates interference, making it difficult for mission control to guide the spacecraft. This means the probe must make many decisions on its own, using onboard systems to keep itself safe without waiting for instructions from Earth. Each of these challenges alone would be enough to end a mission. Together, they make Parker Solar Probe one of the most dangerous projects NASA has ever attempted. Yet, despite the risks, the mission continues to push closer, breaking records with every orbit and gathering data that scientists once thought was impossible to obtain. A mission this dangerous could never be left to chance. Before launching the Parker Solar Probe, NASA spent years preparing for every possible outcome. Every detail, from the smallest screw to the massive heat shield, was tested, retested, and pushed to the limits. Nothing was assumed to be safe until it had survived the harshest trials engineers could imagine. One of the greatest challenges was designing the heat shield. This shield, called the thermal protection system, had to withstand temperatures above 1,300 degrees Celsius while keeping the instruments behind it at room temperature. To achieve this, scientists created a unique carbon composite material that could absorb the Sun's heat and still protect the delicate systems inside. Building it took years of research, because no shield like this had ever existed before. NASA also prepared for the unknown. Since the probe would enter regions of space where no spacecraft had ever been, engineers had to think about dangers they couldn't fully test on Earth. To handle this, they gave the probe advanced autonomy. It can detect when it is turning in the wrong direction, when it is overheating, or when something threatens its survival, and correct itself without waiting for help from Earth. This is critical because signals from Earth can take minutes to reach the spacecraft, and in that time, disaster could strike. Astronauts were not directly part of this mission, but their training and experiences inspired the planning. NASA borrowed lessons from past human missions, where backup systems, redundancy, and constant monitoring kept crews alive in space. Parker Solar Probe carries multiple layers of systems for power, cooling, and navigation. If one fails, another takes over instantly. The mission was built with one thought in mind: expect the unexpected. By preparing for every scenario, NASA gave the Parker Solar Probe the best chance of surviving in the most hostile environment ever explored. Behind every mission, there are not just machines, but people. The Parker Solar Probe may be an unmanned spacecraft, but it carries with it the dreams, dedication, and courage of thousands of men and women who built it. For the scientists and engineers at NASA, this mission is more than just a project. It is a part of their lives. Many of them have spent years, even decades, working on it, knowing that one mistake could mean the loss of everything they built. The human factor is also about courage. Even though no astronauts are physically aboard this probe, the risks are deeply personal. Every decision made by the team involves enormous pressure. They know that space is unforgiving, and yet they choose to face that challenge. In a way, the probe becomes an extension of themselves, carrying their hopes into the most dangerous environment in the solar system. It is also important to remember the astronauts who paved the way for missions like this. Their bravery in past missions, from the Apollo program to the Space Shuttle era, showed humanity what was possible. Many of those astronauts understood that they were risking their lives for knowledge and progress. Today, engineers carry that same spirit into robotic missions like Parker, where human presence may not be physical, but human courage is still at the core. The families of those who work at NASA also feel the weight of these missions. While the probe is a machine, the people behind it sacrifice time, energy, and often years of their lives to see it succeed. It is this human spirit, this willingness to take risks for the sake of discovery, that makes Parker Solar Probe not just a machine flying through space, but a symbol of humanity's endless curiosity. Every mission has a moment where the risk reaches its peak. For the Parker Solar Probe, that moment comes each time it makes its closest approach to the Sun. These encounters, called perihelions, push the spacecraft to the edge of survival. During these times, the probe dives deep into the Sun's outer atmosphere, closer than any object has ever dared to go. At that distance, the spacecraft faces unimaginable conditions. The heat shield is blasted with temperatures over 1,300 degrees Celsius, while the instruments behind it must stay at a safe room temperature. The cooling system works constantly, pumping water through small tubes to prevent the spacecraft from overheating. If the system falters for even a few seconds, the mission could be lost instantly. Communication with Earth also becomes a challenge during these critical passes. The Sun's powerful radiation creates so much interference that NASA cannot always stay in contact with the probe. This means Parker Solar Probe must survive those hours completely on its own, relying only on its built-in systems to correct any problems. In those moments, the team on Earth can only wait and hope that their creation makes it through. Another danger is the sheer speed of the spacecraft. As it swings around the Sun, Parker Solar Probe reaches speeds of more than 690,000 kilometers per hour, the fastest speed ever achieved by a human-made object. At that velocity, even a particle of dust could cause serious damage. Yet, the probe continues to push forward, surviving each close encounter, and sending back data that scientists once thought was impossible to gather. These critical moments are the heart of the mission. They are tense, silent hours when everything hangs in the balance. And each time the Parker Solar Probe survives and transmits new discoveries, it is not just a victory for NASA. It is a victory for all of humanity. With so many dangers, some may ask, why risk it at all? Why send a spacecraft into such a deadly environment when failure seems so likely? The answer is simple, because what we can learn from this mission could change our future. The Sun is not just a glowing ball in the sky. It is the source of life on Earth, but it is also a force of destruction. Violent solar storms can release massive bursts of energy, sending shockwaves across space. When these storms reach Earth, they can damage satellites, shut down power grids, and disrupt communication systems that we rely on every day. In the worst case, a giant solar flare could even cripple technology on a global scale. By flying into the Sun's atmosphere, the Parker Solar Probe is giving us information we have never had before. It measures the solar wind, the charged particles that constantly stream from the Sun, and helps us understand how these winds are created and how they affect Earth. It studies the Sun's magnetic fields, revealing the secrets behind solar flares and eruptions. Every piece of data it sends back helps scientists prepare for the future, so that one day, we may be able to predict solar storms before they strike and protect our planet from their damage. But the mission is not just about protecting technology. It is also about knowledge itself. Humans have looked up at the Sun for thousands of years, wondering how it works and why it behaves the way it does. By daring to fly so close, NASA is answering questions that have puzzled scientists for centuries. In doing so, Parker Solar Probe reminds us that exploration has always been about more than safety. It has been about curiosity, courage, and the belief that discovery is worth the risk. From the very beginning, space exploration has always carried danger. Every rocket that launches, every probe that flies, every astronaut who leaves Earth takes a step into the unknown. The Parker Solar Probe is perhaps the most daring step of all, a spacecraft sent into the heart of the most powerful force in our solar system. It faces heat that should melt steel, radiation that could fry electronics, and speeds that defy imagination. Yet, against all odds, it continues its journey, teaching us more about the sun than we have ever known before. It is proof that even in the face of overwhelming danger, human determination does not stop. This mission reminds us of something important. Progress has never come without risk. The Apollo missions, the shuttles, the Mars rovers, all were gambles that could have ended in failure. But without them, we would not have the knowledge we hold today. The same is true for Parker Solar Probe. The danger is great, but the reward, the chance to understand our sun, protect our planet, and push the limits of human achievement, is even greater. In the end, NASA's most dangerous mission is not just about surviving the sun. It is about proving that discovery is worth the risk. It is about reminding us that the human spirit is built for exploration. And it leaves us with one powerful thought. Without danger, there can be no discovery.